Hey students, welcome to 8.1 Lesson 1. So, not too much of an intro, let's get right into the actual work. So you should have your notes, pencil, calculator, get all the materials that you need ready because we're about to get started. So if I can direct your attention to the screen in front of me, this is Onenote. You guys seen me teach from it. For those that have never accessed it, make sure you use that link that I've given you in Google Classroom. It's also available on my Derby website. So everything is going to be in here. So if you feel you want to watch this video and follow along, great. If you feel you want to rather just look at the notes fully written out and copy it and learn it on your own, just like you would be looking at the textbook notes examples, go right into the notebook and get into it. So with that being said, here we go. I'm going to be looking at 8.1 lesson set Monday, and first and foremost, okay, is the key ideas, as we always often start. The key ideas for this chapter or this section, there's just a few, okay? It's actually a lot easier if we use a diagram. So let's draw a nice, lovely circle, okay? And in this circle, I'm going to put a couple features here, okay? I'm going to draw it like this. So I have a green line, purple line, or pink, your choice. And here's how I'm going to define it, okay? First and foremost, circle. You guys know what a circle is. Many of you have experienced it, but the official definition is that in a circle, all right, all points are equal distance from the center. So here's a fancy math word for saying that from the center, okay, any point on the exterior of this circle is going to be the same distance. All points are equal distance from the center. And that's important because it's basically going to go ahead and get us right into our radius definition, okay? So a radius is right here. It's R, right? Just to make sure that I got it coded right, let me switch back to green and erase that. Radius is R, okay? It's basically the distance from the center of the circle to its edge. Distance from the center of a circle. And I'm going to use this notation. It's a circle with a dot. That's just a geometric notation. Distance from the center of a circle to the edge. So that's just the radius. Okay? And the diameter is D. Okay? That's the purple line or pink line. So for a diameter, the simplest way to think about it is that it is twice the radius. Okay? So some people in your book or whatnot, you'll see a formula called D equals 2R. Okay? You don't really need to memorize a formula. You just need to know that the distance always double the radius. Or if you have a radius, distance is always... Okay, let me backtrack. The diameter is always twice the radius, and the radius is always half the diameter. Okay, so that probably sounds more confusing than what it actually is. Okay, so just keep in mind that we'll probably deal with radius more than anything else. All right, so let's get into the other ones. Okay, pi. You do know what pi is. We've seen it pretty consistently. Here's that crazy little symbol, double lines with the little swoop. We are also going to use 3.14 or 22 over 7 is a good approximation. Okay? Personally, I'd rather use the pi key that is on your calculator. Most of your calculators have that, especially if you have a graphing one. If not, use 3.14 to approximate pi every time, and that's something many of you are familiar with. All right, the last concept on here is called circumference. Okay, C, all right, is what we're going to call circumference. And circumference is the distance around the circle. Distance around, all right, a circle. So think of it as the quote-unquote perimeter. Okay? So D is our diameter, radius R is going to be R, and then we got one more, capital C, and that's our circumference. Okay, it's a distance around a circle. Let me move that so you can see the whole thing. Okay, so think of that as the perimeter. So these are the key ideas. All right, nothing more to really need to know other than these. At this point, pause and catch up if you need to. In about 3 seconds, I'm going to move on to the first example. All right, Here we go. Example 1's very quick. You don't have to write this example down unless you really feel like you need to. It's just showing you the relationship between radius and diameter. So for A, it says the diameter of a circle is 20 feet, find the radius. If the diameter, you can always tell because it goes right across, if the diameter is 20 feet, the radius is 10 feet. It's just going to be half of that. Mental math, not much more work than that. For B, this time though, it says the radius of a circle is 7 meters. Find the diameter. So that means the diameter in this case is 14 meters. It's double that. Okay, so that's it. You don't have to write this example down unless you really feel you need to, but that's just showing you the relationship. Let's move on to the heart of this lesson, which is example 2, circumference of the circles. Okay. So for circumference of the circles, the big thing to note is that you need to make sure you know what you are given. So in the first example, I'm given half, comes from the center, that's R. So R equals 5. In the second one, I'm given all the way across, so that definitely looks like it's a diameter. So I'm going to go ahead and use our formula, C equals 2 pi R, and plug in the appropriate information, 2 times pi times radius, which is 5. And then I usually multiply the numbers together and put the pi right afterwards. Technically, this is called, all right, in pi form. You can leave it as this, 10 pi inches, because that's an exact answer. But if we're going to approximate it, when I put it in my calculator, I'm going to use this little approximation symbol, it comes out to be 31.42 inches. I expect everyone to round to the nearest hundredths, usually when we're doing these type of problems. Hundredths is pretty good. But if you leave it in jumping into algebra 2 there. If you leave it in pi form, that's appropriate. You'll see that a little bit later in math, but punch it out and you should be able to round it. For the next example, okay, the only trick to this problem is that I'm going to use C equals 2 pi R, and instead of using 28, I have to use 14. That's key, okay? So I'm going to kind of put a little star there to make sure you note that. I'm going to use 14 because it's half, all right, half of that diameter. Finishing this off, it becomes 28 pi. Even though we got 28 again, that does not represent the radius or diameter. It's just how the math came out. And then from there, I'm going to go ahead and approximate it. It's 87.96 millimeters is the units. Don't forget our units. So this would be our final answer. Some of you who are pretty savvy will notice that there is a formula in the textbook for diameter when finding the circumference. So C equals pi d is also acceptable. Okay, so if you have the diameter, you can just use pi d. But personally, this C equals 2 pi r is a very common formula. As long as you can find the radius of any object, if you're given the diameter, you can find the radius. It's just half of it. Just stick to one formula. But if you feel like using this one, no problem. Okay, so at this point, feel free to pause this video. I'll wait 3 seconds and move on to the next example. All right, here we go. And the last example for today, basically we're going to explore the perimeter of a semicircle, okay? And if you look at this semicircle, right, it is exactly 1/2 of a circle, okay? So what that means is that in a semicircle, if we want to find the perimeter, okay, so I'm going to trace on this. If we want to find the perimeter, I basically want this right here, excuse my really messy tracing, and I have to include this at the bottom, which is the diameter. So I'm going to add that pink line, and I'm also going to add that gold line together. That's the perimeter of this shape. But if I want to find a semicircle, that pink line, you can think of it this way. I can find the circumference of a full circle using that formula, but then at the end, I got to divide by 2. I got to divide by 2 because it's just half of it. But notice something. 2 over 2 cancels out. Okay, so the actual formula for the circumference of a semicircle simplifies very simply to C equals pi r. Okay, If you don't want to remember this new formula, all you have to do is find the circumference of the full circle and then just divide by 2 at the end. Okay, but for our purposes right now, I'm just going to use c equals pi r, and in this case, the radius is 3 because I have to take half of that distance. It's 6 meters, and c is approximately 9.42. Okay, 9.42 meters. So the pink line, the pink curve is 9.42 meters. So the perimeter overall is 9.42 plus that 6, which comes out to be 15.42 meters. And that's my final answer. So to recap on semicircle problems, okay, you can go back to the original c equals 2 pi r and then just divide by 2 at the end, or you can use c equals pi r knowing that the 2's are going to cancel out before you even start anything. Okay, your choice. With that being said, pause this video as needed. I'm going to wait about 3 seconds and show you the on your own problems. All right, here we go. Let's scroll to the OYO. So in this OYO, let me go ahead and maximize that for a little bit more screen real estate. In your OYO, I've given you 5 problems I'd like you to try. Okay, so 2 and 5 are finding the circumference given radius and diameter. 7 and 8 are semicircles. Then I got a lovely little bit more advanced kind of problem down at the bottom, 18. Okay, so what I'm going to do right now is I'm going to pause the video for about 10 seconds. Okay, after the 10 seconds, the answers are going to magically pop up. So feel free to pause your video. Okay, work through these problems, and then scrub to the end, near the end of this video, and I'll go ahead and show the answers. All right, we should be returning here, and the answer should have magically popped up. Here you go. So check your work as you have finished all the OYO. The only thing I'm going to note, okay, so 2, 5, 7, and 8 are pretty smooth, but for number 18, there are 2 circles. The big thing to note is that on the yellow circle, okay, the circumference of the yellow circle, okay, is going to be from the center all the way to the end here that I've highlighted in blue. So you need to use the radius of the purple plus that 2.5 feet that they have given to find the actual radius of the big yellow circle. So that comes out to be 7, and I've highlighted that in green right here. Okay, so with that being said, okay, this is the end of this lesson video. Feel free to pause this section to double check that you got all the OYO correct. Okay, at this point, I'm gonna end this video and direct you to Google Classroom, and Google Classroom will have the rest of the practice for Tuesday already organized for you. Okay, so this concludes lesson 8.1. Thank you.